We are standing up to cancer, and we want you to stand with us this Friday.
Joining us this morning is Timothy Bolger. He's a PhD assistant professor, Department of Molecular and Cellular Biology at the University of Arizona. Timothy, thank you for joining us.
Well, thank you.
And I actually have a little fun fact for you, so bear with me while I read this. But 47 of the researchers the American Cancer Society has previously funded have gone on to win the Nobel Prize.
Oh, wow.
And no other private, not-for-profit health organization has even come close to that record. And you, my friend, are receiving some society funding for your work at U of A. So perhaps one day we could be reading about your research and you could win the Nobel Prize.
Perhaps.
How do you feel about that?
I wouldn't say that's very likely, but you never know. So, you know, that would be great. Obviously, that's the pinnacle of the profession for researchers.
It really is.
You're very humble. And what kind of research are you doing?
So the kinds of the research that we're interested in is doing something that's going on deep inside cells called gene expression. Mm-hmm. And so you may have heard of DNA, the genetic code. Mm-hmm. So DNA is really an instruction manual to tell the cell how to make the different kinds of proteins and enzymes that are necessary for the cell to do the things that it does. And so that genetic code that has to be converted into these proteins and enzymes, and that process by which that occurs is called gene expression, the expression of the genes. Okay. So we're interested in a basic way how gene expression works. Mm-hmm. And how it may be going wrong in cancer. It's already known that there's a lot of alterations in gene expression that happen during cancer, and so we're interested in figuring out how that actually contributes to the progression of cancer.
And how do you even begin to figure that out? You make it sound like this is how it happens, right? But to me, I'm like, wow.
Sure. Well, I mean, it's a lot of different experiments and different kinds of things that have been developed over many years, using different kinds of scientific equipment to peer inside cells, to look at them, to grind up the cells and see what's inside them. Different kinds of experiments like that. Yeah.
And what fueled your interest in cancer research?
Yeah. So I really think of the research that I'm doing as having two goals, both of which are things that drive me. One of those is the desire to improve human health and to help other people. So certainly the cancer connections of my research are important for that. It's very basic research, but it definitely leads eventually, hopefully, to some kind of improvement in human health. And the other part of it is I just like to try to figure out how things work. So the cell is a very intricate and complex machine, and so it's a real challenge just to try to figure out how it works.
And let's talk about the partnership between the national organization and U of A. Sure.
So the American Cancer Society supports a number of researchers at the university. At the university, we rely on having outside funding in order to do our research. We couldn't do the things we do without it. So it's great to have organizations like the ACS and the Stand Up to Cancer Foundation to help us carry out our research.
And you were talking about gene expression and how it works with DNA and deoxyribonucleic acid. I just had to throw that out there. Thank you. But what kind of cancer are you looking into? Are you looking into just the generic cancer, or are you looking at like brain cancer, breast cancer?
Right. So one of the genes that we're studying in the lab has been associated with several different kinds of cancer. So what we find out may have application to several different kinds: liver, lung, breast cancer. But the closest link is actually to brain cancer, okay. To a form of that called medulloblastoma, which is the most common brain cancer in children. And this gene that we're studying has been found to be highly mutated in patients that have medulloblastoma. And so we're trying to both figure out what this gene does normally in cells, and that can hopefully tell us what is going wrong in these cancers. And then we're also studying specifically what these mutations might be doing to the way this gene is functioning in cells.
And quickly, let's talk about the event coming up.
Sure.
How can people RSVP for it? Tell us what it is.
So Stand Up to Cancer is doing a national telecast on Friday evening. I think it's at 7 o'clock. It's an hour-long telecast. They're having all kinds of celebrities, musical acts, things like that.
Fun.
Locally, there's the American Cancer Society chapter in Tucson is having a viewing party. People can sign up for that by going to the Stand Up for Cancer website. And there's a place there to click and sign up to come to the viewing party if you want.
Excellent. Timothy, thank you so much for joining us today and telling us about the event as well as the amazing work that you're doing at U of A.
Great. Thank you very much.
Continue to do what you're doing for all of us.
I'll try. Thank you.
The Stand Up to Cancer viewing party is this Friday at the Marana Middle School auditorium starting at 6 p.m. The $15 entry fee includes refreshments, commemorative luminary, and door prize giveaways, with proceeds going to the Cancer Society. For information, visit standuptofinishthefight.org.